Hello, good morning everyone. Welcome to this video. This is Mike Water, and in this video we are going to talk about organic chemistry, and much more specifically we are going to look at polymers. And one of the polymers that we'll be focusing on today is terylene, that you need to understand. So what you can see on the screen is the structures that we are able to use in order to come up with this polymer called terylene. Now, before we get to dive into what is happening, so the structure that you see is normally called benzene 1,4 dicarboxylic acid. Now, this is very complex. Of course, you don't have to know how to come up with this one, but let me just explain what is happening. So this part, the circular part, is the benzene, and then these two are what we call the functional groups. Okay, these are what we call the functional groups. So functional group. Okay, and then the same applies with this part. Okay, this is a functional group. So the 1,2 is based off on the location of these two functional groups, the COOH. And once you understand that the COOH means that we are looking at an organic acid, which is called carboxylic acid. And then the di is based off on the fact that we have two of these COOH. And the other thing that you need to know is when you look at 1,4 is just the location of these functional groups. When I start counting going in the clockwise direction, you find that this is on the first carbon and this is the one there. So 1, 2, 3, 4. And this one, the second functional group, is on the fourth carbon. Okay. So in order for us to get terylene, we also need another reactant. Okay, another reactant. This is called you can say ethane. Okay, 1,2. So this one, an organic alcohol, has got the functional group called the OH. So we have this one as well as this one. So once you understand that, and then you are good to go. So those are the functional group. Now there are two of these functional group. Okay. So we have 1,2. Okay. So when you count, this is first carbon. So this is on the 1, then 1, 2. So you have another OH. Okay. Now when you are looking at polymers, okay, so there is a reaction, type of reaction that you need to understand. There is what we call condensation, polymerization. So this is a type of reaction which occurs for these other polymers to be formed. Of course, there is what we call addition polymerization. But when you are looking at condensation polymerization, it only focuses on the reaction of the functional groups. Functional groups. So that's the most important thing, functional groups. Now, in this case, you know that this is a functional group and this is a functional group. And then in the other alcohol, this is a functional group and this is a functional group. So what's going to happen is that it is only these functional groups, okay, that will take part in a chemical reaction, not this thing at the center, not this thing at the center. So we tend to ignore all those. Now, when you have an organic acid reacting with the alcohol, what you're going to get is you're going to get the H2O as well as an ester. So this ester is the polymer that we are going to get. Okay? And this polymer is normally what we are calling the terylene. Okay, this is a polymer that you are going to get. So let's see how that happens. Okay, So in order to ignore all these complex middle parts, we are going to use so we are going to react the two, meaning the acid and an alcohol. So what you need to understand is that the part in the middle won't be shown, as well as this part will not be shown. So what we just need to show is we sort of make some blocks, okay? So the blocks will represent that complex part. So C, then just put on the first part. You're going to just put these two on the carbon, okay? So you're going to have this, then the same here, okay, then plus this one, the alcohol. So we are going to just have the OH there attached to this block. Okay, so we are going to form something here. So what will happen is that this part, okay, so that part is going to react, and once it reacts, it forms H2O, and you are going to have something like that, okay? Now, once that reacts now, forms water, so what remains here is the oxygen, and there you just COH. So you can have again that part. Okay, so this part is just C, then just C, the oxygen there, then dash this other oxygen to this part, this oxygen there, then attach to this, then attach to the OH. Again, the most important thing there again is that this part, okay, this part and the other hydrogen is going to react again. So at the end of the day, what you're going to have is C, okay? You're going to have the CO, this part, and C, this part. Okay. So now you find that this part is just going to repeat itself. It's going to repeat itself again. So this is going to attach to another one, okay? So another like this thing. Okay. So you're going to have okay, so just like that. So this thing will just continue repeating itself. So when you look at this part, okay, this part that is repeating itself, okay, this part, okay. So this as a functional group of COO. So now this COO is a functional group, the functional group for the esters. Okay, that's what you need to understand. So therefore, when you're looking at the name of the polymer, in this case, this terylene, okay, because of these, or rather this repeating unit, the linkage that is linking between this and this, meaning the alcohol and the acid, okay, the alcohol and the acid is normally what is referred to as ester. It's what we call ester linkage, and this ester linkage is just going to repeat itself like that, now forming what is known as something you can call polyester. So polyester, and the way you can know that is because of this COO, and therefore terylene is called a polyester because of that ester functional group. That's all you need to understand, and you're good to go, okay? And for your own information, when you're looking at what is called condensation, polymerization, is that only the functional group will take place, only the functional group. So thank you so much for watching, and I will see you in the next video. Thank you so much.